Hello, everyone. Once again, thank you so much for your time. Today, I'd like to continue on our discussion on EMC consideration. Our topic for today's discussion is a continue on the previous video. Okay, this discussion will be on the shielding effectiveness. This will be the part B series, which we're going to emphasize on refraction. Today's video will be the part 24 series discussion on EMC. The earlier on discussion, I have put the video link under the description. So please go through the video if you are keen to know more about EMC. This is my email. If you have any question regards on today's discussion, please drop me an email. Before I continue, I sincerely urge you guys to support this channel by pressing the like and subscribe button. Sad to say, most of the video in YouTube is based on entertainment. There are lesser and lesser video on education or knowledge sharing. Hence, guys, please support us in order to see more video on knowledge sharing. Thank you so much, guys. Okay, so these are the equations that we have defined earlier on. Let's quickly understand all this equation. Okay, so this E0 is the incident wave. E1 is the amount of wave that successfully penetrate through the first boundary. So in short, this is the first boundary. This is the second boundary. E1 is how much is able to successfully penetrate through the first boundary. As for E2, okay, E1 will be the incident wave. E2 will denote as the amount of field that successfully penetrate through the shield. As for electric field, okay, which is on your left, magnetic field is on your right. So let's study on the electric field first. Okay, for electric field, okay, when the incident wave hit the shield, okay, most of the field will be reflected back. Okay, later on, I'm going to show it to you why. As for magnetic field, okay, when the incident magnetic field hit the shield, most of them will be continue penetrate through the shield. Very little amount will be reflected back. Okay, again, I'm going to show it to you. As for the second boundary for electric field, very little will be reflected back. Most of them will be able to penetrate through the second boundary. So this is for electric field. For magnetic field, okay, most of the field will be reflected back. Very little amount will be able to penetrate through the second boundary. This is for magnetic field. Okay, I'm going to use equation to convince you what I have said earlier on. Before we start, okay, let's quickly revisit this diagram here. Under the near field, okay, if E field is the predominant, okay, we know that there is a high wave impedance. You can see from this diagram here, this is the distance versus the wave impedance. You can see that E field in general, they have a high wave impedance. As for magnetic field, predominant, they actually has a smaller wave impedance. As you can see from here, the value are much smaller as compared to E field. So with this, okay, we are ready to understand under the first boundary. Okay, so this is what I mentioned under the first boundary here. Okay, so let's study on electric field first. Okay, so this is the equation that we have derived earlier on. I mentioned to you, if the wave impedance is electric field, okay, the electric field will have a high impedance. So when electric field has a high impedance, which means that Z1 is many times larger as compared to Z2, which is mentioned here. Okay, because electric field has a high wave impedance, and because of this, I assume that Z1 is many times bigger than Z2. And with this, okay, I actually can remove away Z2 because Z2 is a very small number as compared to Z1, okay, which I actually obtained this equation here. Let's take a close look on this equation. Okay, I know that Z1 is a very big number. So this will be a very big number. Z2 will be a very small number. So from here, you can see that a small number divided by a very big number, you can see that this E1 is actually a very, very small number. From here, I conclude that E1 is a very small number, means that most of them actually reflect back. So this is what I mentioned earlier on the first boundary. Most of the electric field will be reflected back. Okay, so now let's quickly study on the magnetic field. Again, this is what we have derived earlier on. Okay, remember for wave impedance for magnetic field, okay, is actually a very small number. So for this case, I assume that Z2 is many, many times bigger than the wave impedance of magnetic field. From here, okay, I can omit away the Z1 because Z1 is very, very small as compared to Z2. So in result, I actually obtain this number. So from this equation, you can cancel away the Z2. So you actually can see that, okay, H1 is about the same as H0, okay, which means that most of the incident wave will be able to penetrate through the first boundary. This is what I mentioned earlier on. For magnetic field, okay, very little will be reflected back. Most of the magnetic field will continue to penetrate through the shield. Let's quickly study on the second boundary. Okay, so again, these are the equation that I have computed earlier on. The second boundary for the wave impedance, okay, it will be a very large number for electric field. So I conclude that Z1 is many, many times bigger than Z2. And because of this, I'm going to remove away the Z2, which I result in this equation. I actually can cancel away the Z1. You can see that E1 and E2 is about the same, okay, which means that most of the incident wave of E1 will be able to successfully penetrate through the second boundary, okay, which means that very little amount of wave will be reflected back. Okay, so therefore, for electric field, we conclude that on the first boundary, okay, most of them will be reflected back. When they actually penetrate through the shield, okay, most of them will be able to penetrate through the second boundary. And in result, E1 is almost the same as E2. Okay, so let's study the magnetic field. For magnetic field, okay, we can assume that the wave impedance is much, much smaller than Z2. Okay, which I denote over here. Z2 is many, many times bigger than Z1. And because of this, I'm going to remove away Z1. In result, I actually get this equation. Okay, remember, Z2 is a very big number. Z1 is a very small number. So a small number divided by a very big number, okay, you can imagine that this H2 is going to be a very small number. So when H2 is very small, which means that most of the incident wave of H1 will be reflected back. Okay, so with this, let's do a conclusion on magnetic field. For magnetic field, under the first boundary, most of them will be able to penetrate through the first boundary. Very little amount of magnetic field will be reflected back. When they reach the second boundary, the situation changed. Most of the incident wave of H1 will be reflected back. Very little amount of wave will be able to penetrate through the second boundary. This is the case for magnetic field. With this, I'd like to end my discussion. Please help to like and subscribe. Thank you so much, guys.